MRC is configured through the Oculus MR function library nodes in Blueprint or using these functions in script. The first function that we may have to use is set tracking reference component. This allows us to set a scene component that the camera should be following. By default, the camera follows the first player controller, but depending on how your game's player character is set up and how your game's locomotion works, this may not be the correct component to align the camera with the game capture. If that is the case, you want to use the set tracking reference component to set a different tracking reference, which should be locked to the center of the play space. Get tracking reference component will then give you a way to check what component is being used. Another important Blueprint function is the set MRC scaling factor node. This one is used if your player pawn is scaled up or down, which affects how the tracked head and controller motion map to the in-game player motion. Without scaling, the scale is usually 1:1 between the Oculus track component and the objects in Unreal. So if the user moves their head 1 meter to the left, the player's head position in the engine also moves 1 meter to the left. If we scale the player pawn, this ratio changes. 2x scaling means that the same movement now moves the player head position 2 meters to the left in the engine. In this case, the MRC scaling factor needs to also be set to 2 so that it can be accounted for when positioning the MRC camera to ensure that the game capture aligns with the real-world camera. If you set your player pawn's scaling value to something other than 1, use this to set the MRC scaling factor to the same value. This only supports having all dimensions scaled by the same factor, meaning the player's pawn's X, Y, and Z scaling values must be identical. Get MRC scaling factor gives you a way to check the scaling factor currently in use. The Blueprint function is MRC enabled and is MRC active, allow you to check the status of MRC so that you can potentially change things like rendering features or transparency when MRC is on, to improve performance or reduce visual artifacts with MRC. Is MRC enabled indicates that MRC can be used in this game session, but is not necessarily on at the moment. This can be due to the app disabling it manually at the time, or in the case of Quest, not having OBS connected, but is waiting for a connection. Active indicates that MRC is currently being used and is capturing. We'll go more in depth about where and how you can use is MRC enabled in the next section. The last function is get Oculus MR settings, which gives us access to a collection of settings that can be read and modified. These settings are written to and read from the engine INI file and can be changed there by the user. As a developer, you can use this function to override those set by the user as needed. These settings persist across level changes and control various properties of the game capture. This is also how you control turning MRC on and off at specific times or for specific levels by setting the isCasting variable. The remaining settings are more feature-specific and are applicable to Rift MRC only. For more information, see the documentation included. If you have designed your game without MRC in mind, you may run into some incompatibilities in your existing artistic choices or level design with MRC. Here we'll go over some of the common issues and ways to solve them. The first issue is body or hand models. If your game renders a model for any part of the player's body, you may find that this interferes with MRC as you'll be rendering a part of the virtual body on top of the person's actual body in the video. Here, you may want to set some parts of the body components to only be visible in the headsets through the Only Owner See option on the component. Open up Motion Controller Pawn_Darts Blueprint. In the Components tab, with the HUD arrow selected, inside the Details panel, under the Rendering section, you will see the Owner No See toggle as well as the Only Owner See. Some accessories or visual effects such as bracelets, hats, particles, or glow effects may still look good rendered in MRC, so experiment with these to see what looks best. Headlock HUDs and UIs are other items that may require you to hide them from the MRC camera depending on your implementation. Another common issue with render performance is transparency. When rendering, transparent or translucent objects are generally blended with previously rendered object in the scene, and a new color is written to that area. However, with the foreground section of MRC, due to the hardware limitations of GPU supporting only pre-multiplied alpha, we can't calculate the correct alpha values or colors in the foreground part of the composition as this is blended with the backdrop color. At this moment on Rift, transparent object will be blended with the backdrop color, and on Quest, transparent objects will not be rendered in the foreground. If you rely heavily on transparency in your game, you may want to test how critical they are in the foreground, potentially turning them opaque when MRC is active or allowing them to be hidden from the foreground. In your game, you may have tight corridors or rooms with walls or objects close to the player. For MRC, this may be a problem, as the MRC camera can end up obstructed by a wall or large object between the camera and the player. To help alleviate this, you may want to take a look at your game and determine if you can rearrange these obstructions in a way that is friendlier for MRC. Performance is also something that you may want to test with MRC enabled, as rendering a third camera will require additional rendering resources. If your game already has minimal performance headroom without MRC enabled, you may find significant performance issues when it is enabled. If this is the case, one possible solution would be to use Is MRC Active to enable or disable certain expensive, non-essential visual effects. Examples include using fewer particle effects, lowering draw distance, reducing the use of transparency, and reducing mesh, texture, and scene detail. There you have it. Now that you know how mixed reality capture works in Unreal, you can implement or use it with your Oculus project to capture mixed reality footage. In the next 2 courses, you'll be learning more about how to optimize your project and the tools to do so.